In this video, we're going to go through and graph the parent functions for 4 different functions that we learned about in Algebra 1. We're going to look at the constant, the linear, the absolute value, and the quadratic parent functions. And make sure that you record these in your notebook and have them written down, because you will be expected to know them backwards and forwards as we then move on and start looking at the child graphs that can be created from these parent graphs for these 4 different types. So we're going to start by looking at the constant function first. And the constant function equation is represented in function notation by f of x is equal to 1. So that's our function notation and equation that represents the constant function. Now, I know that sometimes f of x can be a little bit tricky to read, so if you would rather write this in the less fancy way, we can write y instead of f of x is equal to 1. So what we're going to do is we're going to select values for x and find what y is for those particular values for x. So essentially we need to graph y is equal to 1. Now what many of you might be noticing here is that there aren't any values for x for this particular equation. And what that's telling you is that x can be whatever you want. So we can have x's right around the origin of -2, -1, 0, 1, and 2. And because there's no x here, what this is really telling you is that y is always equal to 1. So the constant function is actually one that is very easy to graph. So all we're going to do here is we're going to graph the xy pairs onto our coordinate plane and create an accurate graph. So when x is -2, y is 1. So we go to our coordinate plane and we plot. X is -1, y is 1. We plot. X is 0, y is 1, and plot. X is 1, y is 1, and x is 2, y is 2. And what you should be noticing is all of those little dots are forming in a horizontal line. So the constant function here is just a horizontal line where y is equal to 1. So that is our constant function equation, table, and graph. Now our last step here is to calculate our domain and range. Remember, domain is talking about all of the x values that we need to create a particular graph, and range is talking about the y values. So here, if I look at all my x values, what I'm noticing is that this graph goes forever to the left and forever to the right, which means that to create points all along this line, and to create that horizontal line, I need every single x value that is existing in our number system. And the way to write that and record that for a domain is all real numbers. Then from here we look at our range. Remember, the range is talking about the y values. Well, if you look carefully up here at your table, you're noticing that your only y value that you need to create points on this graph is y equals 1. And if you look here, you'll notice that every single point, while the x's could be anything, y is always equal to 1 for every single point there. So for our range, all of our y values that we need to create that graph, we have y is equal to 1. The second parent graph we're going to take a look at is the linear function. And the linear function is represented by the equation f of x is equal to x. So now from here, if we want to translate this into less fancy wording, we can just put y is equal to x. So we're going to create a graph of y is equal to x. So to start off, we're going to select x values. So we have x is -2, -1, 0, 1, and 2. And because for this particular function we actually have an x value, what we need to do is we need to take each x value, substitute it in, and find what y is equal to with that particular x value. So if we start with x is -2, if we plug x is -2 in there, we get y is equal to -2. So when x is -2, we're discovering that y is also -2. And then if we move on and we test out when x is equal to -1, so we're going to plug that in here, we have y is equal to -1. We then plug in 0, so we're testing out when x is equal to 0, what is y? Well, we have y is equal to 0. And then we start with the next one, so we do an x is equal to 1. So we have y equals, we put 1 in for x, 1. And then the last one, we have x is equal to 2. So we have y is equal to, and we plug 2 in, 2. So now we can go through and we can actually plot this graph. So we have x is negative 2, y is negative 2, x is negative 1, y is negative 1, x is 0, y is 0, x is 1, y is 1, and x is 2, y is 2. So we can see that this is forming a diagonal line, and if we connect those dots and draw the points all the way through, fully extend that line, we can see that we have a diagonal line where every single pair has x and y matching. So when x is a number, y is that same number. So that's our linear parent function. Now our last step here is to identify the domain and the range. So here remember that domain is talking about all of the x values. And if I look at this graph very carefully, I notice that the graph is going forever to the left and forever to the right, which means that our domain for this graph is all real numbers. And if I look at my range, which represents my y values, I notice that it's going forever up and forever down. So I need every single y value to create points on that graph. So my range is all real numbers as well. So moving on to the absolute value function, our equation for the absolute value function is f of x is equal to the absolute value of x. And hopefully in your brains you're thinking through what that absolute value function actually means. So from here we can change this into less fancy verbiage, which is y is equal to the absolute value of x. And hopefully you're remembering that absolute value works that by putting any number in to the absolute value, it finds that number's distance from 0 and changes the number to always being positive. So absolute value will always produce a positive number. So in order to calculate some points to graph this, I'm going to pick some x values between negative 2 and 2, and I'm going to substitute those values in for x and calculate the corresponding y value. So let's start with x is equal to negative 2. So we take x is equal to negative 2, we plug it in, we get y is equal to the absolute value of negative 2. Remember that absolute value finds distance from 0 and turns everything positive. So the distance from 0 for negative 2, turning that into a positive, is just 2. Then from here we can do x is equal to negative 1. So again, we go y is equal to the absolute value of negative 1. And again, absolute value finds distance from 0. So this is going to be equal to 1 unit from 0. It turns it positive. Now when x is 0, we do y is equal to the absolute value of 0. Well, 0's distance from 0 is 0. Then we have x is equal to 1. So we do y is equal to the absolute value of 1. Well, 1's distance from 0 is 1 unit, so that remains positive. And then we do when x is equal to 2. So we have y is equal to the absolute value of 2, which is 2 units from 0. So now if we go and plot these, we have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So because of that absolute value function turning everything to be positive, we can see that we have a V-shaped graph. Now from here, our last step is to determine domain and range. Remember, domain is focusing on all of the x values needed to make a graph. And what I notice here is that this graph goes forever from left to right. So our domain for this particular graph is all real numbers because we're using every x value as this graph goes forever to the left and forever to the right. And then our range values here, the y values that we need to make this graph, what I notice is I don't need any of these y values down here to make this graph. If I didn't have the whole bottom portion, I wouldn't need it. It would be okay. I could still see my entire graph. So all of the y values that I need to make this particular graph start at 0 and go up from 0. So our range is going to be represented by an inequality, and we're going to say we need all of the y values that are greater than or equal to 0. And last but not least, we're going to take a look at the quadratic graph. So the parent function for the quadratic graph is f of x is equal to x squared. And again, we can turn this into a less fancy version by writing y is equal to x squared. So we have our function there of y equals x squared. And then from here we create a table of values. So we have x values from -2 all the way up to 2. So we're going to calculate those values. So we have when x is equal to -2. So we have y is equal to -2 squared. Well, -2 squared is -2 times itself, so -2 times -2 is 4. Then we have x is equal to -1, so I have y is equal to -1 squared. Well, -1 times -1 is 1. I then move on to x is equal to 0. So we have y is equal to 0 squared. Well, 0 squared is just 0. Then move on to x is 1. So y is equal to 1 squared, which is 1. And then we move on to x is equal to 2. So we have y is equal to 2 squared. Well, 2 squared is equal to 4. So if I pair those up in my table, I have 4, 1, 0, 1, 4. So then from here, I go over and I plot those points. So x is -2, y is 4, x is -1, y is 1, 0, 0, 1, 1, and 2, 4. So from here, I can draw my graph. And I can see that I have that general U-shaped graph. So the last thing I need to do here for my quadratic function is identify the domain and the range. So if I look closely here for domain, I'm looking at all of my x values. Remember that for domain, I'm looking at all of the x values I need to make points on my graph. And I notice for this one that it goes forever to the left and forever to the right, which means I need every x value, so my domain is all real numbers. And my range, we actually start with y values at 0 and go up. Notice I don't need any of these y values down here beneath the x-axis. So all of the y values that are above 0 and equal to 0 will help me to create points on my graph. So I can represent my range by saying y is greater than or equal to 0. So at this point, you should have a solid understanding of all of the 4 basic parent graphs, and you should be able to graph them at any time and identify their domain and their range.